Imagine looking not excessively far off and seeing a daybreak that includes a portion of the sky. NASA has conveyed photos of a previously unheard-of idiosyncrasy where a star named Betelgeuse went crazy, catapulting a gigantic piece of its surface mass. The event is known as a surface mass ejection, and according to the Space Organization, the release was multiple times the mass of a typical solar flare from our Sun. Analysts describe the event as watching great improvement in real time, with a star taking off such colossal chunks of its actual structure. Incredibly, the tragic impact of this truly red behemoth is upsetting much of what we know about the universe. Why did Betelgeuse go crazy, and how could that impact the universe? Let's sort it out. Celestial bodies are composed of many stars and are often associated with fables and legends. They are still used for navigation today. One such star is Betelgeuse, which is among the largest and brightest stars in our night sky. The brilliant ruby-red shining star known as Betelgeuse is located in the upper right shoulder of the winter constellation Orion, the Hunter. When observed carefully, stargazers recognize it as a raging giant with a multi-day-long pulse of regular beats. Due to its striking orange-red color, Betelgeuse is easily recognizable. It's great for convincing skeptics that stars do indeed have different colors. Betelgeuse is also called Alpha Orionis and is the second brightest star in the constellation after the blue supergiant Rigel. Despite this, Betelgeuse is designated as Alpha Orionis because of its prominence, brightness, size, and bronze-red color. It is perhaps one of the most notable stars in the night sky. This star also served as the inspiration for both the character and the movie Beetlejuice, making it even more significant. Betelgeuse is the seventh brightest star visible from most of North America, Europe, and Canada, and the 10th brightest star overall in Earth's sky. While it is relatively close to Earth, astronomers cannot pinpoint its exact distance, estimating it to be somewhere between 430 and 724 light-years away. Betelgeuse is the brightest red supergiant star closest to Earth in our galaxy. There are only about 200 red supergiant stars identified. The Sun's radius is over 1,000 times smaller than that of Betelgeuse. If Betelgeuse replaced our Sun in the solar system, its surface would extend past the asteroid belt and even beyond Jupiter. This means Earth, Mars, Venus, and Mercury would all be engulfed. Betelgeuse is also about 20 times more massive than the Sun, with 12,000 to 26,000 times its luminosity, and it is visible from 548 light-years away. This star has a surface temperature of around 3,600 Kelvin, making it cooler than the Sun. Nearly 13.3% of Betelgeuse's radiant energy is visible light. If the human eye could perceive all wavelengths of light, Betelgeuse would outshine Sirius as the brightest star in the night sky. Betelgeuse loses about one solar mass every 10,000 years. The red star is surrounded by a cloud of material ejected unevenly, forming a nebula approximately 30 astronomical units in size. This is equivalent to the distance between the Sun and Neptune. The Sun regularly ejects mass into space through solar flares, small portions of its outer corona, a phenomenon called coronal mass ejection, CME. CMEs and surface mass ejections occur at separate times. When a star releases part of its unstable outer atmosphere, it creates a CME. In our solar system, CMEs frequently affect Earth, damaging satellites and power grids when directed toward the planet. CMEs can also endanger astronauts in orbit. In 2019, Betelgeuse underwent a massive surface mass ejection that expelled material into space, cooled, and formed a dust cloud. This cloud temporarily dimmed Betelgeuse's brightness as observed from Earth. Additionally, the star's consistent rhythmic pattern of pulsations was disrupted. This event was unprecedented, with the mass ejection releasing 400 billion times more material than a typical CME. The disturbance caused the star's surface to oscillate like a bowl of jelly. Andrea Dupree, an astronomer at the Center for Astrophysics, stated that Betelgeuse's internal convection cells might be in turmoil, while its photosphere struggles to recover. Astronomers have tracked Betelgeuse's rhythmic pattern for over 200 years, but it no longer follows this predictable cycle. All red supergiants, including Betelgeuse, are in the process of dying. Observing this cycle offers astronomers valuable insights into stellar evolution. Most stars in the universe are powered by nuclear fusion, which eventually runs out, leading to fascinating transformations before a star's death. When a star is born, it primarily consists of hydrogen, which undergoes fusion in the star's core to form helium. Over time, as hydrogen is depleted, helium fuses into carbon, then carbon into oxygen, and so on. When fusion can no longer sustain the star's gravity, the core collapses, triggering a supernova explosion. Supernovas are some of the universe's most powerful events, releasing more energy than 10 billion suns. Stars change color throughout their lifetimes, from the hot blue hues of youth to the cooler red tones of old age, depending on their evolutionary stage. As Betelgeuse evolves, its journey offers a fascinating glimpse into the life cycle of massive stars. When Betelgeuse finally exhausts its nuclear fuel, it is expected to explode in a supernova, a cataclysmic event that will be visible from Earth even during daylight. This explosion will scatter heavy elements like iron and nickel into space, contributing to the formation of new stars, planets, and possibly even life. The aftermath of such an explosion would leave behind either a neutron star or a black hole, depending on how much of the core collapses under gravity. For now, Betelgeuse remains in its red supergiant phase, but the signs of instability suggest its life is nearing its dramatic finale. Scientists believe the star could explode within the next 100,000 years, a brief moment in cosmic terms, but it's unlikely to happen in our lifetime. Betelgeuse's prominence in the night sky has made it a cornerstone of human observation and imagination. Ancient cultures wove myths around its presence, often associating it with warriors and gods. In modern times, it continues to inspire science fiction and popular culture while serving as a laboratory for studying stellar evolution. As our technology advances, we are better equipped to observe and understand phenomena like Betelgeuse's surface mass ejection. With telescopes like the Hubble Space Telescope and the upcoming James Webb Space Telescope, scientists are unraveling mysteries that once seemed beyond our reach. These observations not only deepen our knowledge of stars but also enhance our understanding of the universe's origins and eventual fate. The story of Betelgeuse is a reminder of the dynamic and ever-changing nature of the cosmos. It also highlights humanity's enduring quest to explore and comprehend the vast expanse of space. As we continue to watch this colossal star, we are not just witnessing its transformation, we are also discovering our place in a universe filled with wonder and infinite possibilities. Rationalist Tycho Brahe in 1684 exceptionally alluded to Betelgeuse's tone as having a bronze color. 3 centuries prior, Chinese stargazers had portrayed the star as having a yellow appearance, perhaps inferring that Betelgeuse was once a yellow supergiant. Astronomers could gain a better understanding of how red stars lose mass in their final days before exploding in a brilliant supernova blast. As Dupree notes, we've never seen a massive mass ejection on the surface of a star before. We are left with something we don't completely understand. It's a totally new phenomenon that we can observe directly and resolve surface details with Hubble. We're watching stellar evolution in real time. Yet, it's unclear whether this evolution predicts Betelgeuse's imminent supernova blast, as the results are so astonishing. NASA cautions that Betelgeuse might not have reached the end of its life, even though it is nearing the end. Stellar time is long, and red supergiants die quickly by comparison. According to NASA, Betelgeuse will explode within the next 100,000 years. Betelgeuse has been the subject of extensive study since the 1st century BCE. More recently, a researcher named Serafina Nance and her team worked to learn more about the likely timing of the supernova explosions of red supergiants like Betelgeuse. They simulated the star's behavior over time and compared their findings with field observations. Why did Betelgeuse suddenly dim, contrary to its usual cycle, when it's not expected to explode for another 100,000 years? Betelgeuse has been ejected from its home in the Orion OB1 association, which includes the stars in Orion's belt, and has been observed traveling through the interstellar medium at a speed exceeding 30 kilometers per second. By mid-February 2020, Betelgeuse had lost 2.5 times its brightness, dropping from magnitude 0.5 to magnitude 1.7 after starting to dim significantly in October 2019. By February 17, 2020, Betelgeuse's brightness had remained stable for almost 10 days, and the star had begun to brighten again. However, Betelgeuse appeared to have stopped dimming completely 5 days later, effectively ending the dimming event. Given that there were no major changes in the infrared, a study concluded that the star's dimming was likely caused by a massive cloud of circumstellar dust. Dust absorption was ruled out as a significant factor in another study using measurements at sub-millimeter frequencies. The dimming appeared to be caused by enormous star spots. Further research showed a dramatic rise in Betelgeuse's brightness between May and August 2020. Betelgeuse is so close to the Sun that it is incredibly difficult to observe from Earth. Before 2020, when Betelgeuse dimmed again, it was also 0.4 in brightness, according to observations made with the SOFIA satellite in June and July 2020. The star had faded by 0.5 magnitudes since its previous ground-based observation in April. This surprised everyone because the maximum and minimum brightness levels were expected to occur in August and September 2020, and again around April 2021. Betelgeuse's brightness is known to vary widely, making predictions difficult. The dimming suggested that a second dimming event might occur much sooner than anticipated. The discovery of a second dust cloud coming from Betelgeuse, linked to June 2020 observations, suggested that a cool patch on its photosphere might be the cause of the dust. In August, an independent study confirmed this hypothesis. The dust is thought to have been created by gas ejected by the star. Studies done in 2022 using the Hubble Space Telescope suggested that a dust storm may have been caused by a surface mass ejection. The material was propelled away from the star's surface, thousands of kilometers outward, where it cooled, compacted, and formed a dust cloud that obscured the star from Earth's perspective. The dimming, which began in late 2019 and lasted for several months, was noticeable even to casual observers who saw significant changes in the star's brightness. Surprisingly, the 400-day pulsation cycle of the supergiant has disappeared over the past few years. Astronomers have been tracking this cycle by analyzing changes in Betelgeuse's surface movements and brightness variations. This disruption reveals the magnitude of the impact. Astronomers have now developed a scientific hypothesis to explain the disturbance. The star is also slowly but visibly regaining strength, and its photosphere is recovering. However, its usual cycle has been lost, and the star's interior is vibrating like a bell that has been struck. A massive stellar surface mass ejection has never been observed before. There is still much we don't fully understand. This entirely new phenomenon allows astronomers to directly observe and study stellar evolution in real time. When will Betelgeuse explode? Probably not in our lifetimes, but no one truly knows. Could happen tomorrow or a million years from now. Will Earth be destroyed by Betelgeuse's supernova blast?
Well,
the impact of Betelgeuse's explosion will not destroy life on Earth, as it will occur too far away to have any effect. Astronomers estimate that for a supernova to be dangerous to humans, we would need to be within 50 light-years. Betelgeuse is more than 500 light-years away. Instead, everyone on Earth will be treated to an exceptionally stunning view of a very bright star in the night sky. Finally, due to Betelgeuse's location, astronomers will be able to study the star when it undergoes a supernova blast. Betelgeuse is not currently visible in the night sky, so don't go looking for it. Even if it exploded right now, we wouldn't see much of it yet. However, it will be in the evening sky during August. Betelgeuse may have already gone supernova, but its light hasn't reached us yet. Betelgeuse is not just a prominent star in the Orion constellation but also plays a vital role in the study of stellar evolution. Its size and unique characteristics make it an excellent laboratory for understanding the life cycles of massive stars. The star is classified as a red supergiant, a category that includes some of the largest and brightest stars in the universe. Observations suggest that Betelgeuse will eventually undergo a massive transformation, leading to a brilliant supernova event. This explosion is expected to produce a neutron star or possibly even a black hole, depending on the remaining mass after the blast. Researchers are eager to gather more data about its behavior, particularly concerning mass loss rates and surface changes, which can provide insights into similar stars across the universe. In addition to its scientific significance, Betelgeuse has also captured public imagination. Cultural references, such as the classic 1988 film named after the star, have cemented its place in popular culture. As it nears the end of its life cycle, the fascination surrounding Betelgeuse continues to grow, highlighting its importance both scientifically and creatively.